Well, hello, good morning. Thanks so much for coming and joining me here in my shop today. It is October 20th, and we're going to be focused on just a couple capacitors, or at least that's the plan to start. One here and one over here. And first we're going to operate the set, and we're going to measure the grid voltage as best we can. It's a little bit challenging to measure a grid voltage in some circuits, such as this one. But we're going to give it a shot and see if it isn't very close to zero, to the chassis voltage, or whether it's been elevated by a leak in this capacitor here. That's what we want to find out. Now I'm going to show you something a little odd. In fact, you can see it in this camera. Just get a little closer here. I noticed this right away when I came in here. This resistor, well, I think it's a resistor, is installed inside the socket. Grounding tube, for lack of a better word here. Each of these sockets has an open tube there. Can you see that? On top. And this one they've gone and shoved a component in it, I guess, for shielding. I guess. I don't ever see anything quite like that. And the grounding of this part is done with a strip. Can you see that in the camera? Again, a little hard to see, but it's not a wire, it's a strip going down. Solid metal strip. And talking about that, that reminds me. They also found this mysterious loose part here with a metal band soldered into it for some reason that's well beyond my experience. I have no idea why something like that would be there. Okay, so number one is turn on the set and measure that voltage. Okay, let's do that. Let's just do that. Let's just hang on a sec. Make sure everything is good to go. So we have it set to FM. That'll be fine. And I think we're good here. Okay, put it on. I'll use my indicating meter here to do this. Probably use a couple different meters. And the reason for this is that this measurement is very dependent on the impedance of the voltmeter, or the load the voltmeter will place on the circuit. Okay, so I'm going to put this on a nice grounding spot. Here's one. So I actually don't expect much. Here we go. Don't expect much voltage, but we'll see. Oop. There's the radio. Okay, so I can get the grid right off of here. So I'm going to watch this meter. I've got it set pretty high, 50 volts, so I don't expect it to even move. You might hear this coming out of the speaker when I do this too. Oh, did you see that? Now, is that because I moved the lead up too high and hit something else? The meter leaped up. It didn't sustain. Let's try that again. Did I touch something up here? I did. I touched the end of this resistor. That's what happened. Okay, never mind that. Here we go. Watch the meter. Went up a little tiny amount. Okay, so I'm going to put this on the 1.5 volt scale. So this is a positive voltage on the grid here of about, it would be 0.3 volts. Let's just go on the other side of this resistor. Should get the same thing. Yeah. Well, I think that voltage is coming from the far side of this brown capacitor here. And if we look at the other side of that brown capacitor, what is pushing on it is this. Oh, it's not as much as I thought. Oh yeah, so it's going to be 67 volts or something like that. So on the 150 volt scale, this is the plate voltage of the detector, 60 volts. Yeah, in some cases this can be much higher. It could be like 200 volts pushing on it, but depends upon how many tubes they've got in the radio and stuff like that. So 60 volts pushing on this end is causing a little bit of charge to come out the other end of the capacitor, get on the grid, and push it a little bit positive. Let's check it again. And I'm watching for a jump in the meter when I make contact. No, there's no real jump there. So it's a pretty rock solid. This time I'm reading 0.5. It's going up. It's going up and up. It's still going up. It's taking time for the charge to bleed over, or something else is happening. Capacitor is becoming more leaky over time. Can't believe that. So there's a resistor to bleed this charge off, and I think it's a 500,000. Wasn't that some kind of variable resistor or something? Let's leave this operating for now. We'll come check it again in a minute. We're going to jump over to the schematic and just look at how this charge, what is drawing down the charge. We know what's building it up, leaky capacitor. What's drawing it down? Why isn't it 67 volts? Okay, here's the output tube circuit, and the capacitor that we're concerned about is this one right here. And on this side of the capacitor, either here or here, I get the voltage reading I got. 4, 5, 6 volts rising. I'm suggesting it's coming from this circuit here, which is running around 70 volts or so, something like that. And because there's no, well, I was going to say, yeah, look at that variable resistor here. What is going on with this? R34. And I think this is the volume control. This is one tone control here. This must be the other tone control, and that's about all it is. And it would look like some kind of feedback arrangement feeding into this resistor. So some of the signal here is applied to the grid, and it's adjusted out by this. Where's this variable resistor? Aside from the variable resistor, this resistance is 600,000 ohms. So this can be much higher. This can be 1,000,000 ohms easily. 500,000, million ohms. So it's right in the normal range. And so any charge that's building up in here is bleeding down through this resistor. But it's pretty big. So charge coming in, charge going out. And the result is the pressure in here builds until the flow out equals the flow in. And that's what's happening. Now, why is it rising slowly? Perhaps this is warming up in some way. I don't know. Capacitors don't normally warm up. Is there anything else unusual? Just the unusual thing is this. Could there be some kind of flow out of here through this 1 nanofarad capacitor with ears? Well, there's a ground right here. Could that be the case? Would this guy be part of the picture? I guess it could be part of the picture. Well, what we should do is we should change this one. This is definitely the first door through which the charge is flowing. We close this door, and I think, I think we'll be okay, because the voltage here should be 0 relative to the chassis, not plus 0.6 volts. Did I say 6 volts? 0.6 or 0.7 or whatever it is now. So the overall grid bias here was high. I wonder, is that because of this grid potential building up here? We'll find out. I'm going to measure this again. We should measure this again. We'll do that right now. What is the voltage drop on the cathode? What is the voltage drop on the cathode resistor? And do I remember what I'm doing here? It's right here. Forgot to change the scale. Okay, so it's going to be 15. Luckily, these meters are pretty hard to damage. 15 volts. Wasn't that what I read before? Okay. 9 volts. Well, that's not 15, that's for sure. I don't know. Maybe I'm remembering it wrong. 9 volts. Holy jumper! That's exactly what I didn't want to do. Okay, that won't have hurt anything. He says. Hurt my feelings. Something smells a little warm again. Okay, now I'm measuring the grid voltage again. Okay, we're on, we'll say 5 volts now. See if I don't cause a spark. Don't cause a spark. So on the now we're at 2.5 volts. A 1.5 volt scale, right over. So you see the voltage is building up, building up, building up. Maybe it's steady at this point. We don't want that 2.5 volts there. Okay, now that sort of proves that this capacitor is leaking too much to remain. This is a very sensitive part of the radio when it comes to leaky capacitors. At other locations you can have capacitors like this leaking to this degree. It won't make any difference to anything, but not in this spot. Okay, we're going to cut it off. Now, the last time I went through this with another radio, I found a very similar situation. I replaced the capacitor and the voltage didn't go away entirely. It remained a small voltage there. Pretty sure it was not due to a capacitor leak. So how does a grid get a voltage like that? I don't know. We'll see what happens this time around. So I'm going to go ahead and change out this capacitor. We'll also test this once we get it out, and we'll see what the meter, what the test shows about it. Okay, I've got one side of the new capacitor installed. So you might see a little dot on my capacitor there. Dot. I put that there after taking some time with some of these capacitors and determining which side was the outside foil on the capacitor. See, the capacitor I took out has a outside foil marking on it to indicate which lead is connected to the outside foil, and so I'm matching that. And I'm not sure if it really has much of an impact. I suppose again, just like leaks, they're important in some cases, not so important in others. Usually you want the outside foil attached to the low impedance side of the circuit, and often that's actually right to ground, right to the chassis or something like that. That's so the outside foil begins to act like a shield. The capacitor has its own, using itself as its own shield. There we are. Okay. This red clip lead is on here to keep me mindful of which wire I should be soldering to. So when I cut the original component away, I immediately put a clip lead on, because if you do this work or something similar to it, you know, you look away, and when you look back, you can't be sure of what you're looking at anymore. Which is why surgeons have their tools handed to them while they continue to stare into your stomach or whatever it is they're working on, but they don't want to take their eyes off it. So I'm just checking for short circuits. Some bare wires around in here that are quite close. Okay, so we have the new capacitor in there. Will this have changed that voltage, or will I have an inexplicable situation on my hands? At least something I can't explain. Let's see what happens here. I personally believe this is something you should be checking in every radio that comes across if you're working on this kind of stuff. At the very least, check this grid capacitor on the output tube. Okay, we're all ready. Here we go. Really close to that piece of wow, it's really close. Remember, I found this part that wiggles, and the it looks like the post that everything is soldered to has come off and is just in a stupid spot. It's just like a millimeter away from contacting the place where I was soldering. Whew. I'll have to look into that next. Maybe that's part of the story here. Okay, everything's fine. Volume up. You can hear the radio. That's a good sign. Now, I'm going to go on that grid and watch this meter. Is there egg on my face? The meter didn't move. Okay, we're on the 1.5 volt scale. Hey, you didn't look. That's good. That way I could have embarrassed myself in private. So that's just my hand on here. Okay, onto the grid. Remember last time it got up to, well, on the 5 volt scale, it got up to 2.5 volts on it. Let's see what it's got now. There's nothing there. There is nothing there. Let's look again. Meter as sensitive as it can be. Okay, so there's a tiny... Oh, Jim, don't jump like that. Just keep calm. A tiny amount. You know, we're talking about 0.01 volts or something like that. Let's see if it builds up. I don't think I have an antenna on here. No, we're not getting anything. Okay, no problem. Good. Okay, so we have solved the invisible problem of a positively charged grid on the output tube. And that's going to reduce the overall grid bias. It's going to increase the current flow through the tube. Well, let's check the tube cathode bias too, just see if that's changed at all. Okay, cathode bias can be found here. So that's 7.5. It was 9 before, wasn't it? Now that's 7.5. And what did the book say? The book said minus 7.5 was the ideal. Wow. Well, there we go. Okay, don't do any more testing because the story's good now. So here's something I learned in life. Investigations, like police investigations, medical investigations, any investigations into repairing a radio, any kind of investigation continues until the investigator is satisfied. It doesn't continue until the truth is known, although maybe that's the case. What really ends an investigation is when the investigators are satisfied. Look at that, I left this clip lead on in here. It's not a smart move. Okay. So think about that for a minute. Okay, that's 60 seconds of thinking on this important topic of what ends an investigation. Okay, now that has huge implications for us in our lives, by the way, what I just said. And it's my own personal philosophy, which I don't generally share on my channel. I generally keep my own philosophies to myself. Because how do I know if they're the right philosophy to have? How can I possibly know? Okay. Now we're going to go after this other capacitor that was on the plate that's barfing its guts out. This long brown one. The purpose of this one? Maybe I'm going to delve into one of my books a little bit. Oops. And just review. Let me turn this off before I forget. And while I'm doing that, I can drink some coffee. Fantastic. it's not like me to bring a book in on a video like this, but I'm gonna. This book is called Elements of Radio Servicing. This is a fantastic book. And here it talks about C12, this capacitor. This capacitor on this diagram is in the same position as the one in the radio that's popped its guts here. C12, very small one here, 0.005. In the radio, I can't remember what it was in the radio. From the plate to ground on the plate line that goes to the output transformer. And what does it say about it? So we'll go over here. Just make sure that's the only place it mentions. Out here on C13. So here we are. Condenser C12. The high AF bypass. But what do they mean by that now? High frequency AF bypass? I don't know. Often comes up as the cause of a dead radio. Its position in the receiver is not only at high DC potential, but also where the AC signal potential, the audio variation, is at its highest. This high voltage causes frequent breakdown of the insulation, resulting in a shorted condenser, which shorts the audio signal from the primary, the T6, and also shorts the power supply at this point. Conditions quickly found in a voltage check, blah blah blah. Condenser C12 might also open. However, a radio will rarely come in for this defect alone, since an open C12 will merely increase the high frequency response. The customer may overlook this. If you have a tone control in the front, you can compensate to some degree. And besides, most of us get a little older. We need that high frequency stuff to hear it. This is the key point. In some radios, an open C12 may cause high frequency oscillation, and you may not hear it, but it may be there. If this is the case, bridging C12 with a similar condenser or with a higher capacity condenser is the standard check procedure. And it just talks about you better put a high voltage capacitor in there. Put a good one in there is what it says. Okay, so that capacitor's purpose is not exactly clear to me still after even reading that, although the effect it has is to bring down the high frequency response a little bit to some degree, and I think it's about oscillations. I think it's about stopping oscillations myself. Okay, so we're going to go after that capacitor. Hey, we got to test the one I took out. Well, we'll take out the next one. We'll test both these at the same time. So the next one's right here. Let me get my cutters here. It's a very cold day today. It's only 2 degrees outside, and there's ice on my deck, which is not melting. I'll leave enough lead. I can test the capacitor. Oh, scare me there. A little pop coming out of the speaker. There's another one. So little charges remaining in the radio. Okay, it's right where the blue wire comes around. Can't get in there with my fingers. So I don't forget. Yes. Well, I won't forget now. I've studied this enough. I won't forget. Missed again. This usually works first time every time. Got it. Okay. So you see this capacitor here is connected right to the chassis, right where I have my meter clip lead. Let's just pop this out. There he is. Pretty dusty. Guts hanging out. So what's going to happen here is this material coming out is really a failure of the hermetic seal of the capacitor. The idea is you don't want moisture going in. It causes a couple different problems. But whether the capacitor itself is actually no good, well, we can only find out by testing it. Let's do that. Come on over here. And there is where my magnifier's been all this time. I've been looking for this all over my house. It's sitting right there. Hardly a day goes by where I don't look at stuff through my magnifier. Okay, we get the two capacitors over here. Now the capacitor checker I'm using is really intended for capacitors that are doing the kind of duty that I'm talking about. That's in old radios with high voltages. And modern radios do not have these high voltages because transistors don't require them, whereas tubes do. So what this will do is it's going to put a DC voltage on the capacitor. We can raise the voltage up, starts at 50 volts and goes up. And if there's zero leakage of current through the capacitor, like a new capacitor would be, then the magic eye over here will just stay open like you see it now. It's a little hard for you to see, but there's an opening. There's the lower part is, it's very hard for me to show this on camera. My eyeball works great. The camera's not so good here. I think you can get wind of it there. There's a darker area at the bottom of the magic eye, in case you haven't seen one before like that. Okay, so we're set to 50 volts. Yes, it says 25 here, but in fact it's 50. What does it do? Okay, it opened right up. 150. Well, it's showing itself to be a pretty good capacitor, but in the radio, this was still enough of a leak to disturb the grid. What's the rating on this guy? I can't see. Here. Put a little more light on. 220 volts AC. Doesn't say. Just says 220 volts AC. Well, we're at 150. We'll give it 250. We'll give it 250. Turn my lights back down. Well, you can actually see the pie better that way, can't you? Turn it back up. If I just shadow it a little bit by standing right here. Okay. 250, what do you do? So it's starting to struggle now to open up. So this is a very important test for me because of what I did with the radio. Saw the leak on the radio, saw the leak disappear with the new capacitor. That defines this capacitor as a bad one. So now I'm in a bad capacitor here, and I'm finding out that it takes 250 volts to reveal its badness. Because at 150, still looking pretty good. So that this is a qualitative test, and I need to calibrate it in, for me personally when I use it. That's great. Really good opportunity there. Now what about the cooked up one? What did I do with the cooked up one? Here it is right here. Okay. This has got 500 volts written on it. Starting gain at 50 volts. There we go. Right open. 150. Open. 250. So it's actually not in very bad shape. This amount of leak is probably unimportant in the circuit it's in. The circuit it's in has lots of current available, so a little tiny leak isn't going to do anything. Don't want to go any higher with it. So the other thing about doing this, and this is, you can consider the two capacitors they did as samples out of the radio, and the rest of the capacitors are going to be in similar condition. And you can consider this one to be a beat up one. It's still working pretty good. And this one, almost like new, just in a very sensitive position. But I've now put a brand new one in that position. What about all the rest that are like this or like this on the radio? Well, I guess some people would say, oh, you should change them all. And, you know, to some degree, yeah, I suppose. Change everything. Change every resistor. Change everything. But along with doing that comes risk and and expense. The risk being the part that scares me. Because again, you don't think you're going to do any damage to a radio, and then you catch something with your sleeve and you pull it and it hits the floor. That's kind of what we're worried about here. Hey, what was the size of that capacitor? 500 picofarads. So that's a 0.0005. 0005. Okay, I'm going to install a new one. I'm going to just check on the schematic before I do that. Just make sure it matches, and then we'll see what happens. Well, it turns out that capacitor was not a 200, or a 500 picofarad. It's a 2500 picofarad, or 0.0025 microfarad. I put in a 0.002 because that's what I've got. I don't have a 2.5. And what that would do then is a reduction in the capacitance here means more high frequencies get past that capacitor and show up in the speaker. So a little more high frequency won't affect the bass at all. So high frequencies, that's good as you get older. You need that. And it has a tone control in the front that you can adjust anyway, so if it's really quite shrill, I'm sure you can tone it down with the tone control. Now, let's take a look at this weird situation here with this piece of floating metal and all this stuff when I come back after my coffee break. Lots of coffee breaks. Boss doesn't like it. So just to be clear, I don't think that this is necessarily an important thing I'm going to look at. It's a weird thing, and I'd like to get a story behind how it got to be the way it is. Is it influencing the operation of the radio? Doesn't seem to be. So this is just a curiosity, I guess we could say. What is the end of this resistor hooked up to? See that? You can see the piece of metal in there floating up and down. I think the first thing to take a look at is this strangely long terminal strip. What's it sticking out here for? They've got it sticking right out here. Lucky they didn't break that off. They broke it off here. Okay, and then we can look and see. So you can see the structure of this. It has these metal bands going across it all the way. And are there any missing? So it's a hole in a band. So band, hole, fixture on the chassis, hole, band, hole, band, hole, band, hole, 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 and right there is the band, and it's just floating up. I think what happened here is when they were building this radio, they this metal piece came off, maybe from rough soldering or rough handling or something, came off, and the person building it either never noticed or didn't care. Looked at it and went, well, that's okay. Now, maybe it's not quite in the same place where it was originally, but it's really close to shorting. Really close to shorting, right in there. You can see it there. I'll wiggle it. So, what's the deal then? We have to cut it away, bend it into a safer position, and forget about it. I think you bend it into a safer position and forget about it. Cutting a piece of metal like that involves a lot of force. That's one of the ingredients to accidents. And I don't think we need to do any more than just bend it over here, out of the way. It could be that because this piece is here, and in normal view, when you look into the radio, this is blocking all the time, depending upon where you're standing, of course. Maybe that's part of the picture. You made a something went wrong in an area that's hard to see. That's my story. I like that story. That's a good enough story. So I generally think we are done. I'm going to assume that this wire wound resistor, which apparently overheated at some point, overheated because of excessive current through the output tube, and that was due to the leaky capacitor driving up the grid potential, making it positive, increasing the quiescent current, I believe is what you might call it, going through the tube. So this will preserve the output tube, which I think I tested as being okay at this point. Maybe it's even a replacement tube. There are some other capacitors that I would be inclined to replace, but having done the tests I've done with this one, considering the radio works, I just don't see the value in doing it. There's really no value. Okay, well, I think we've got to put this in the cabinet. Oh, I've got a few cleanup things to do. I've got to clean up the dial glass, clean up the buttons, and do a few things like that. And then it's back in the cabinet for a final test. Yeah, there is one more technical thing, and that's hooking up the speaker wires correctly. But I think I probably have video information I can rely on to know which wire goes where. Very good. Okay, here's a quick look at the situation with this radio. I've taken the knobs off so I can clean them properly. And of course, this is what people see, this is what their eye goes to, so you want this to look as good as possible. So you can see underneath the knob, just you know, this is just dirt that's collected over the years and years. The knob's here, the cabinet comes up like that. But this is still a little bit visible, and there's probably stuff in between the knobs here. That's pretty good, actually. But it's all going to get cleaned up. Glass down in here behind the knobs. When you push the knob down, it reveals what it's for. Now, that's not very good, is it? Oh, it actually gives the frequency rate down there. 145 to 3, 510 to 1620, 87 to 100. It's a European FM. It doesn't go to as far as North American FM band. Don't know about today. What goes on in Europe? Maybe it's still the same. Don't know. Okay, I'm going to clean this guy up. One thing I'm going to show you is how I clean the back of it. The back of this. Now, this one looks really rugged, but in some of these, the paint is almost always on the back. Not always, but almost always on the back. Sometimes it's so fragile that if you apply any water to it, and any pressure to it, you'll wipe away what remains of the words and the numbers. That ruins the radio. So I actually use a feather. Now, this one's rugged, but nevertheless, I found that a feather is a great way to, hey, feather duster. Not a discovery. Thought I discovered something. I'm just using this to try to wipe away as much dust from the back as I can. On the back of the glass. And the backing plate. And this radio is not, you can't see through very much at all, just little tiny windows and a little slot up here. So you don't see much of the backing plate. And often the backing plate gets really dirty and it's inconsistent. Now you can see it all. But I can't do too much there. I think it's going to look great. As long as these lights are... So these lights are not like a lot of radios. The lights are lined up with the edge of the glass and they make the whole glass glow. That's not the theory on this one. This one, the lights are trying to throw light onto the backing plate, and then you're looking through, and the lit backing plate is providing the look of the radio, if you like. So all these little squares should light up a little bit. The lights are pretty high up to do that. But that's where they are. Yeah, I wonder if I should do something a little more aggressive with the backing plate then. Okay, going to clean the glass up, knobs up, and we'll see what we got. Buttons up, everything. Just to give you a quick peek of what's involved here, I'm down to cleaning this part here. A little soap on it. So these things you might think are minor. When you look at something like this or anything, the small details that don't look right are disturbing. You may not even really perceive what it is. If your brain is smarter than you are, you will become aware of it without knowing you're aware of it. So if you want things to pop, as they should with this radio, all this stuff has to kind of look kind of newish. And it's pretty easy to do. I mean, it's just dirt. There. Buttons clean, dials clean, looking better. I turned the camera back on because what I just said actually leads to a very important discussion about people. People judge things in two ways, probably more, but two main ways. The content of what it is they're considering, and the form of what it is they're considering. And you look at the form and the content, and you decide how you're going to judge the thing. Let me give you a good example here. Let's say you're sick, you go to the doctor, you go to the hospital, and the two doctors come in to talk to you. One of them has been working for a few hours. He's dressed like a doctor. He's got all the paraphernalia. He's got the right kind of doctor clothes, doctor clothes, surgical outfit, stuff like that. He looks like a doctor. Well, the other guy, well, he's a doctor too, but he's just come off from playing golf. He just got out of the hospital. He heard about you, so he comes running in. He's still wearing his clothes from golfing. Now, you don't really know this, of course. So you have a doctor who looks like a doctor and a doctor who doesn't look like your standard doctor, not what you would expect. He's got shorts on. And the two of them don't agree. And one of them says the treatment should go this way, and the other one says the treatment should go that way. And you got to make a decision. They're asking you, make a decision. Which way do you want to go? How are you going to make that decision? You're not a doctor. You can't weigh the content of what they're telling you. So you might revert to form. I'll go with the guy who looks like the doctor. And different people will lean more and more towards form or more and more towards content. And if you pay attention, you'll find this in yourself and in other people. You begin to recognize those who are making decisions or judgments based on content. Based on form more than content. So what I'm working on here is the form. I'm working on the form of the radio. If someone comes in and sees it, you want it to look great. You want the form to be great. Because later you're going to demonstrate the content. You're going to turn it on and play it and sort of say, hey, look, I can tune this, look at that. So people will have that. But the form part, this is just the way people are, and this is because we have to live our lives, and sometimes we have to make decisions with little information, and we have to base it on whatever we can find. Form is a big part of that. A big part of that. Why do church leaders dress in weird white clothes? Why do they do that? To make the form right. If you think about it, if you witness somebody, like let's say the Pope. The Pope's a great example. Form, it's all about form. Because in my own view, the content is crap, but the form is fantastic. They wear these clothes, they have these performances that they do. All form. Content is crap. So they're going to lean on form. So if you're a person who leans on form, you might be very much attracted to what the Pope has to say. Anyway, not to get too political. That's just a thing about people. You see, when you're trying to fix the radio here, the biggest problem is us. That's the biggest problem with fixing stuff. Okay, now I'm going to clean those knobs up. Stop my speeching. Okay, got it all back together. time to give it a test. But just look at the form of this radio. That's the reason why this radio is still around, because of the way it looks. Isn't it fantastic? Beautiful curved wood. Look at these trim pieces that they've put in. This beautiful gold colored trim everywhere. It's fantastic. And so, yeah, form. Of course, the content in these European styled radios is fantastic also. So, shall we give it a try? That's off. Here we go. Okay, now I've got a little bit of light on in here. I've got a light blasting right on it, so we might not see the light effect in here. Volume down. AM radio first. I can barely see any lighting, so let's cut these guys off. Still barely see it in there. In fact, I think this light's not on. You can see the magic eye. Hey, that's good. I've hooked up to an outdoor antenna. Let's see what happens here. Tuning at 1600, end of the band, coming down. It's doing a pretty good job, actually. Picking up noises only, but that's okay. Now we should start getting stations in and around here, if we're going to get any. Don't tell me it's still doing that tuning thing. Oh my God, it is. Well, it's going to have to stay that way, I think. I don't know. Yeah, so we're not going to pick up anything here. It's because of antenna, I'm sure. We can try a different antenna in a minute. Now, FM on the indoor antenna, on the built-in antenna, what do we get? Oh, it still has that strange tuning thing. Well, it's beyond me what that is. Ever driven a car with play in the steering wheel? I mean, that doesn't happen anymore, but when I was a kid, my friend's car was a 1960 Ford Galaxy 500 with wings. And it had almost a quarter turn of play in the steering wheel. So you go straight down the road like this. It's kind of like that with this. Well, it's just going to be one of those things, I think. Okay, and of course, here in my shop.
It makes a fire. In the Middle East. Or something like. Yeah.
Strangest thing. Makes the tuning very difficult. Crash. Well,
keep it inside. I just wanna let it out, let it out. I don't wanna hide, I don't wanna hide, I just wanna let it out, let it out.
he wants to let it out. That's quite a bit of volume too. Well. guy doing? By any wild chance see this eye operate? Quickly, we'll go into darkness. I'm not seeing much. I can see the eye operating. Okay, things aren't going well here. We'll go back to the medium mode. There we are. There's the eye working. Look at how much brighter it got. Actually, it didn't get brighter. It's just the tuning wings came down into sight, within sight. Back to FM. FM, the bright part just disappeared from view.
Follow shame to the place.
Sounds good.
Your grace ran out. I kept
Pretty sure this is going to work quite nicely out of my shop. Okay, so I may be done with this at this point. I have to discuss with the owner about the way it's operating right now, and is that it's probably satisfactory the way it is. So, and what I could do to this to make it better yet, I'm really not sure. I'm not sure. Okay, well, that's it for now for this guy, and thanks a lot for watching this series. And I think I'm going to revert back to a couple of things I had on my bench earlier. A big tape recorder, because I now have tapes. I have tapes. So I might get a big tape recorder in here next and fiddle around with it a bit. So thanks a lot for watching the series, and you may see this back on my bench, or you may not. See ya.